This is the screencast for section 8.2, example 10, working with indeterminate form infinity to the 0. So again, that's an exponential form. We are probably going to use logs. Alright, so we're going to find the limit as x approaches infinity of x to the 1 over x. Well, if I think about what happens as x approaches infinity, x is going to become infinity, 1 over x is going to become 0, so we do have infinity to the 0. So we have an exponential indeterminate form, so let's start by taking logs. I'm going to find the limit as x approaches infinity of the natural log of our function f of x, which is the limit as x approaches infinity of the natural log of x to the 1 over x. Alright, so now I'm going to drop that exponent in front of the log as a coefficient, which brings the x down to the denominator, because that would just be times 1 over x, so bring the x down. That's simplified, so let's see what happens as x approaches infinity. The numerator, the natural log of x as x approaches infinity, is going to approach infinity. X itself would also approach infinity, so now I have infinity over infinity, and I can use L'Hopital's. The derivative of the numerator, natural log of x, is 1 over x. Derivative of the denominator then is 1, so I have the limit as x approaches infinity of that quotient. Simplify. And now I can think about the limit as x approaches infinity and what happens to 1 over x. Well, 1 over infinity is going to approach 0. Again, that's not our answer. That's the limit as x approaches infinity of the natural log of our function. So, therefore, we can make this conclusion. The limit as x approaches infinity of f of x, the goal we're trying to find, which is really the limit as x approaches infinity of, rewriting it as e to the natural log of f of x. Well, I know the limit as x approaches infinity of the natural log of f of x. That is 0, so it'd be e to the 0, which is 1. The now try problem number 25 says identify the indeterminate form and evaluate the limit using L'Hopital's rule. So 25, the limit as x approaches 0 from the right of 1 plus 1 over x to the x. So let's think about what happens when x approaches 0 from the right. Well, 1 over teeny tiny positive numbers is going to be infinity. So 1 plus infinity is infinity. X, as it approaches 0 from the right, is going to approach 0. It's just by itself. So I do have infinity to the 0, an exponential indeterminate form. So now I'm going to use logs. I'm going to take the coefficient, put that in front of the natural log. But of course I want to make this a quotient so I can use L'Hopital's rule. So I'm going to make that x multiplying by x divided by 1 over x. And now let's think about what happens as x approaches 0 from the right. So 1 over 0 we already talked about is going to approach infinity. So we have the natural log of infinity. So natural log, that's going to approach infinity. And then 1 over a teeny tiny number is going to also approach 0 or infinity. So I have infinity over infinity, which means I get to use L'Hopital's. So now I'll take the derivative of the numerator, which is 1 over what I'm taking the log of, and then times the derivative of what I'm taking the log of. Then derivative of the numerator, or derivative of x to the negative 1, is negative x to the negative 2. So let's think about this simplification a little bit. First of all, I have a fraction within a fraction. So I'm going to take one of these x's in the denominator and distribute it to the other denominator. So that's going to look like this. 1 over now x plus 1, and then just 1x in its denominator. Now instead of dividing by a fraction, I'm now going to multiply by the reciprocal of that fraction, which makes this simplification a little bit easier. The two negatives cancel out, one of those x's cancel out, so I have x over x plus 1. Now I can take the limit as x approaches 0 from the right. The numerator is going to approach 0, the denominator is going to approach 1, so that leaves me with 0 as my limit. Therefore, the limit of the function I'm trying to find can be rewritten as the limit as x approaches 0 from the right of e to the natural log of that function. Well, since I found that limit, I know that that would be e to the then 0, which is 1.